For ICE candidates, we need to identify two processes, sending and receiving. Let's focus on sending first. After we created our RTC peer connection, we set the onICE candidates, which is the function that we will be executing when this particular user creates or finds an ICE candidate. To do so, remember that ICE framework follows a process that consists in 3 steps. Getting the device's IP address, used as stun server or a turn server. That's why when you create an object, you set the ICE servers variable. And what are these servers? These are the ones provided by Google and by Mozilla. We can use the servers for free, but it's not recommended to use it on production, because in such cases you will need to set up your own stun and turn service. So every time a new ICE candidate is found, the onICE candidate event is triggered, which is similar to what happens to the on-track events. Anytime that the RTCP connection receives a remote stream, it will trigger the on-track event, which is the on-at-stream event. So let's create the handler for when an ICE candidate is found. So we're going to create another function. This one is going to be called onICE candidate, the same as we wrote it above. So we're going to receive an event, and in here we're going to check if the event is actually a candidate or if there actually is a candidate. Okay, so we're going to print it to the console, send in ICE candidates. Let's also print the candidate here. And we're going to send this to the signaling server by a minute. Now we're going to add this as a candidate event. Okay, the type is going to be also candidates. We're going to have a label, which is events, candidates. This is going to be equal to SDP M line index. These are some values that are handled internally by the ICE framework. We're also going to set an ID event, candidates, SDP M ID. We also need to send the actual candidates, which is going to be events, candidates, candidates. But we need a comma here. And we're also going to send the room number. Okay, we're ready now. Now we need to be able to receive those candidates from the signaling server. To do so, we just need to add the handler function for the message. So we're going to add it here. Sockets on candidates, which is going to receive the candidates that they receive for the other pair. And in here, we're going to declare a constant candidate equal to new RTC ICE candidates. And we're going to initialize it as DPM line, as DPM line index, event label. And the candidate is going to be event.candidates. And lastly, we're going to add the ICE candidate to our RTC peer connection. Add ICE candidates. Here's the constants that we are using. Now that we have covered signaling, we can let the RTC peer connection do its job and establish the call. Let's now run the app and check if it's working. So we have the application running. Now let's go into the WebRTC training group. I'm going to click allow. I'm going to lower the volume because I haven't felt back in here. So I'm going to do the same on the other room. WebRTC training and go. So I have the call established. We can see that we have these two streams here and we also have the two streams here. We also can see that there's a bunch of messages above the sending of the ICE candidates. We also have those same messages in the other browser. Now let's do something so we can get a more clearer view. Let's add some messages in here. First of all, we're going to create, or we're going to print when we receive the ICE candidates. So we're going to add here, we're going to add cancel log. We're going to add the message received candidates. We're going to print the candidates. We have to replace here. Okay, so now we have candidates. We're also going to make a console log when we create the offer. So we're going to add a message here. Console.log and sending offer. And we're going to print the offer, which is the session description. We're going to do the same when we receive the offer in here. So we're going to print console.log and received offer. We're going to print, I think, the session description. Okay, no, it's events. So we're going to print the events. And we're going to also print the log when we send. So sending the answer. And we're going to print the session description. Okay, finally, we will add last message in here when we receive the answer. So let's write console.log received answer. And we're going to print the event. Okay. Now let's refresh. And we'll also refresh here. Let's get into the room again. WebRTC training. Click allow. And let's do the same in Google Chrome. WebRTC training. Now let's take a look at the messages. The first thing that we do is we send the offer. We have the STP format in here. We can see that there's a lot of information that is sent through the peer in the signaling server. And here in the other peer, we see that we get the offer and it's the same that we have sent from here. Another thing that we do in here is that we send the ICE candidates. We have 3, 4, 5. Well, we have a bunch of ICE candidates that I receive in the other side. We can also see that in here, after we get the offer, we are sending the answer. And if we scroll down, we will see that we received the answer in here. And in the meantime, the peers are also sending those ICE candidates to each other and they are receiving them. This has all happened before the actual call. And when all this data is exchanged and correctly processed on each side, then we are able to have our call. So that's how the call works. And now we are having our video conference, our small video conference application. The last step, I think, that which we are going to add to our application is we're going to make an example of the data channel. So when you're ready, move to the next lesson.